Hi, and welcome to Current Topics in BME ABET Accreditation. This is a webinar provided for all of our PEVs and also the broader BMES community. We were supposed to be joined today by a moderator, Debbie Wells. Unfortunately, due to the incoming hurricane, she was not able to be with us today. So I'll be taking over her portions of the presentation. And allow me to introduce myself. My name is Jenny Amos. I'm at the University of Illinois in Urbana-Champaign. I'm a BMES representative to the Engineering Accreditation Commission, or EAC, of ABET. And I'm a teaching associate professor here in the Department of Bioengineering. And I am going to start today with a few announcements. First of all, this will be recorded, and the recording will be available sometime later next week, along with an archive of materials discussed. You can certainly submit questions at any time using the chat feature. You should see a chat where you can submit questions, and we'll address those questions at the end of our presentation. And also you'll be sent a survey, and we'll ask that you fill out that survey at the end. And that really helps us to make sure that this is serving our community. We'd like you to participate in a poll to help us understand who all we have here with us today. This helps us really tailor our webinar presentations. So if you would please click on the button that best describes you and your role so that we can learn a little bit more about who is in our audience today. All right. Looks like we have mostly faculty who are involved in accreditation, and then also PEVs on behalf of BMES. Thank you guys for joining us. Some staff and also some other people who joined us today for the webinar. So thank you for providing that. It's really helpful for us to understand so that we can use the right kind of information that's really tailored to our audience. We have another question today, which is, where is your program within the accreditation process? So have you previously undergone accreditation? Are you pursuing initial accreditation? Or maybe it's just something you're thinking about in the future. This information is particularly helpful to us as the Accreditation Activities Committee because we're, as you'll hear, in charge of figuring out how many program evaluators and how many visits we might have in a coming year. So let's see the results for that. Great. So it looks like a majority of our attendees today have some previous accredited programs. We still do have initial accreditations, and as you're probably aware, BME has a lot of initial accreditations still, and a few of you are considering applying. So welcome, and hopefully you'll get information that's helpful for that today. One last question is, what are you hoping to take away from this webinar today? Are you a PEV training for an upcoming visit in the fall? Are you just interested or involved in the BME accreditation process? Maybe you're on the visiting side and you're trying to get insight into what that might look like, or of course, all of the above. Great. So a lot of people involved in accreditation. I certainly am as well, so I probably would have clicked all of the above here. Lots of PEVs getting ready for a visit and insight into details of visit. Yeah, especially with some of the changes that we'll be talking about today, it's really good to kind of freshen up every year, and that's one of the main reasons that we do this webinar. So now we'll jump into some of the details. So If you're here, you got an invitation likely through BMES, and BMES is the lead society that takes care of BME and BioE programs through the accreditation or Engineering Accreditation Commission. We do cooperate with several societies, the American Ceramic Society, the American Institute for Chemical Engineers, American Society for Agrobiological Engineers, American Society for Mechanical Engineers, and then the International Electrical Engineering Association. So any of those societies can also help provide insight and then program evaluators for BME and BioE programs. So anytime there is a PEV assigned, that person will be representing ABET and also BMES, and then maybe even another society if they're sent from a different one. So BMES and ABET have a kind of a committee that sits between them that communicates between the two constituencies, and that's known as the Accreditation Activities Committee, or the AAC. And membership for that is approved by the BMES Board of Directors. And the AAC really is the face of BMES to ABET. So it's made up of a chair, a PEV assignment coordinator, a quality assurance coordinator, and then 4 members at large. We also have ex officio members who report directly to the ABET Board of Delegates. And then we have the Council of Chairs corresponding members that sit on our committee while we discuss business to kind of represent the Council of Chairs. So you might want to know who these people are since they've been elected through BMES. This is a list of the Activities Committee for 2019-2020. The stars that you see on there are people who are involved in the webinar that you're part of today. So myself, Paul Benkesser, who you'll hear from later, Benjamin Kelly, and Debbie Wells. And many of these other members are either a member at large or serve on the committee in another fashion. But all of us are really active members and sitting with this committee for 1 to 3 years, depending on our role. So we are the people who will solicit for nominations for program evaluators. So you'll see flyers. We made a 1-page flyer that was sent out to help recruit for program evaluators. A lot of people think that ABET assigns program evaluators. It's actually the society that does, and for BMES, it's the AAC. So we are actually the ones who help assign the program evaluators and the mentors. We're responsible for training our program evaluators, and specifically on program criteria, since that's the criteria that BMES kind of controls as a society. We also look across all of the reports. Every time a program goes up for accreditation, we can see what that report is and look for quality assurance, make sure that there's good consistency across different findings, and also we can look at trends across BME programs nationwide and even internationally to try to just understand better the assessment and accreditation needs. We also are the group that starts the conversation on the BME program criteria, and you'll see at the end we have an invitation to a session at BMES to join that discussion. So most of you who are PEVs will know this, but there's many people on the line who are not, and we would love to invite you to be a program evaluator. So there's a program evaluator application every year, and then there's a training requirement. So program evaluator candidates participate in about a 1.5-day face-to-face training after completing some online work modules through a LMS called Brightspace. And really those cover, really understanding the whole accreditation process inside and out, understanding the role of the program evaluator, how to assess quality improvement of student learning, how to apply each of the criteria, really what to look for in each of the criteria, and then the PEV appraisal process, which is the way that PEVs are actually evaluated to make sure that they are meeting our expectations for professionalism and knowledge about accreditation processes. So some of that is BME specific, and some of that is hosted by ABET, the organization. In addition to training, BMES mentors all of the PEVs. So we have our own training, which you're participating in right now, either live or through the recording. And we do not have observation visits. There are societies that offer observation visits, but BMES does not. What we do is we have a mentorship model. So all program evaluators are assigned a mentor. That's a person that can be a confidant, that's kind of behind the firewall. So you can ask questions to your mentor and get advice on maybe interpretations of program criteria or other accreditation questions. So you've all received your assignments for the year, and you should definitely feel free to reach out to your mentor. They will be there to help you and support you during your visits this fall. There's many criteria within ABET that hopefully you're familiar with. There's general criteria for all engineering programs. This is provided by the Engineering Accreditation Commission. So there are 8 general criteria. There were changes to Criterion 3 and Criterion 5 within the last cycle, and we want to make sure that everyone always just refreshes themselves on the general criteria. We'll talk about some common shortcomings that we see later in this webinar, and then we'll focus in on that 9th criteria, which is not listed here, that Paul is going to cover. So just really briefly, there's 8 criteria. Each of these has very specific goals and language of what is the expectation to satisfy these criteria. And so you should just be familiar with each of these, as well as the new ABET definitions that came out, further defining terms like complex, engineering, design. Those are things that every program evaluator and, of course, every program undergoing accreditation should be really aware of. So do make sure that you refresh yourself on that. Now I'm going to hand it over to our second speaker, Paul Benkesser, and let him tell you more about program criteria.
Thank you very much, Jenny. So as Jenny mentioned, the program criteria are really the only part of the accreditation criteria that our society, Biomedical Engineering Society, is the lead for bioengineering and biomedical engineering programs, has really complete control over. And for training purposes, ABET pretty much leaves it up to the individual societies to provide additional insights and tips and guidance on these program criteria, which we're trying to do here through this webinar, and again at the annual meeting in Philadelphia, which we'll talk about a little bit later. Okay, so let's first distinguish the program criteria from the 8 general criteria that Jenny just mentioned. These criteria are established by the lead societies, in our case BMES. They involve input from constituents and ultimately must be approved by ABET, but generally that approval process by ABET is one that we're really just looking to make sure that what we include in the program criteria fit the definitions of program criteria, which we will talk about here in just a minute. So the general idea here is the criterion 1 through 8 apply to every engineering program. So aerospace, electrical, mechanical, biomedical, so forth, all have the same identical criterion 1 through 8. But the program criteria allows each individual discipline to provide some additional specification to really two of the general criteria. The first being that related to curricular topics, so that would be criterion 5, and the second being faculty qualifications, so that would be supplementing criterion 6. Now, programs really must demonstrate that they meet these program criteria. In other words, these are not something that the visiting PEVs are trying to figure out for themselves, but the expectation is the programs will demonstrate that they meet these specific criteria. So what are we talking about here? Over the next couple of slides, I'm just going to really go through the language of the biomedical engineering, bioengineering program criteria, and then we're going to spend some time breaking it down and looking at some key concepts and key ideas. So recall, program criteria are limited to really two areas, curriculum and faculty qualifications. For our criteria, we have no additional faculty qualifications, so ours is really limited to strictly curricular topics. So as you can see here on this slide, some of the key words that we're going to be talking about and the implications, breadth and depth across the range of engineering and science topics. And then we get into a bit more details. The curriculum must provide graduates with experience in these following bulleted topical areas: applying principles of engineering, biology, human physiology, chemistry, calculus-based physics, mathematics through differential equations, and statistics. The second area, solving biomedical engineering problems, including those associated with the interaction between living and non-living systems. The third area, analyzing, modeling, designing, and realizing biomedical engineering devices, systems, components, or processes. And finally, making measurements on and interpreting data from living systems. So let's take a little bit closer look and break these down. One of the first points I need to stress here is that these program criteria by themselves are not outcomes. They're not like 1 through 7 or the former A through K, in that there is no assessment required or evaluation required of student attainment of these elements of this program criteria, like is specified in criteria 4. However, programs must demonstrate that these topics are part of the curriculum that all graduates of the program are taking. Now, most programs will use things like course syllabi, textbooks, maybe sets of lecture slides, and quite commonly examples of student work as evidence to demonstrate that these curricular topics are part of the program's curriculum. Now, you need to be very careful here. If a program chooses to incorporate in some way, shape, or form some of these curricular topics into their student outcomes, then they are required to follow the requirements of criterion 4 for assessment of student attainment of those outcomes, but only if those are incorporated into the student outcomes 1 through 7. Remember, I kind of emphasized breadth and depth when introducing the program criteria. This is frequently a topic of question, how much breadth, how much depth? Well, when these criteria were written, the intent here in the verbiage was to allow a program either through the title of the program or perhaps through through maybe student outcomes or through educational objectives, have a specific flavor, if you wish, of their bioengineering, biomedical engineering program that would imply perhaps a greater depth in some area. For example, a program may choose to have tracks, specializations. They go by a number of different names. There's no requirement for that, but some programs choose to do that. And so if you're going to have a track in biomechanics, let's say, you would expect, or a program evaluator would naturally expect, that there's going to be more than a single course perhaps in biomechanics as part of that curriculum. So the second point here should be evidence of breadth and depth of curricular topics, again, as defined by the program. So the program is really the one that really sets the tone here in terms of what breadth and depth mean for their specific program. You don't worry about what other people are doing. It's how you're defining and designing your own program. But you have to be very explicit in terms of trying to demonstrate this as part of the program criteria, how you are defining that. More key concepts here. Let's break down some of the individual language of the criteria, the curricular topics. Applying the principles of biology and human physiology. Now, exactly what subtopics within biology and human physiology would one expect to be included in a curriculum? Those are really up to the program to determine. So there is no specific definition of which biological or physiological topics. The program is left to define that for themselves. Now, these do not have to be standalone courses. If they are not standalone courses, then you would need to, specifically point out within syllabi of other courses how these topics are integrated into those courses. The second major portion of the program criteria, solving biomedical engineering problems, including of those associated with the interaction between living and non-living systems. Again, it's up to the program to demonstrate, in other words, show the PEV, where these are included within the curriculum. Typically, with this particular aspect of the program criteria, we frequently see evidence of student work, projects, homeworks, and those sort of things as evidence that these are part of the curriculum. Experience in applying principles of mathematics through differential equations and statistics. So the curriculum, as stated here, it really has to include these topics. Again, they could be in standalone courses. We frequently see that, but there are also examples we've come across where these are sub-portions of other courses where additional topics are contained in those courses as well. So the key idea here is that these are topics, not courses, that are being described within the program criteria. Must prepare graduates with experience in making measurements on and interpreting data from living systems. So the emphasis here really is that not just measurement, but also interpretation. And again, providing evidence in terms of how one is doing it. Don't make the PEV hunt through all your program materials to try to find that. Explain to them, demonstrate to them how this particular topic is being addressed within the curriculum. solving BME problems, including those associated with the interaction between living and non-living systems. Again, there is no specification about what those interactions are or which systems we're talking about. Again, that's up to the program to determine as what is best fits the intent of that particular program. Now, some common issues that when we look across the entire spectrum of engineering programs that the EAC is responsible for, as we're looking through the general criteria here. We'll briefly go through those, and then the next slide we'll share with you some of our observations about issues that seem to be more common in biomedical engineering programs than perhaps other disciplines. Criterion 1, as far as the students, we frequently see issues related to problems with advisement and in monitoring student progress. Criterion 2, the educational objectives. Often constituents aren't as involved in the processes as they are supposed to be. Criterion 3, the outcomes. Attainment is not completely measured in some cases. However, I suspect as we're moving through this transition from A through K to 1 through 7, perhaps next year there will be some challenges here associated with programs transitioning between the former to the latter. Continuous improvement. Frequently, the documentation associated with that is particularly associated with the processes are somewhat lacking. Perhaps some programs are only referring to anecdotal examples of continuous improvement rather than those that are arising out of the processes they've defined for their program. Curriculum, criterion 5, frequently the issues there relate to satisfying the culminating design experience. Faculty, criterion 6. All too frequently, I guess, we see issues with very high student to faculty ratios, or in some areas in covering teaching in certain curricular areas, the faculty in a program may be lacking in number to adequately cover those areas. High workloads, access to professional development opportunities. These are all ones that seem to resonate across the entire spectrum of programs the EAC oversees. Facilities, insufficient space, and increasingly, there is an increasing emphasis now within the EAC about safety. And so we are seeing more citation with regards to safety concerns, particularly in laboratory settings. And finally, criterion 8, institutional support. Sometimes we come across programs where they're having difficulty filling open positions, faculty positions, and others that may have too few staff to really support their operations. So those are kind of common findings across all engineering programs the EAC oversees. But what about biomedical engineering programs? Now this is one of the roles of the BMES AAC. When we go through and review the findings of all the biomedical engineering programs that were evaluated in a given year, one of our responsibilities is to provide feedback to the Council of Chairs about common problems that we're seeing across numbers of biomedical engineering programs. Now, many of these are not different than other engineering programs, but some are a little bit different, many associated with the relative youth of our discipline and younger programs, rapidly growing programs, in other words, programs often experiencing growing pains. So criterion 1, advisements, prerequisites. Now prerequisites by itself, you won't find that term in criterion 1, but sometimes programs where we observe students not meeting prerequisites for certain courses, that tends to often be a manifestation of insufficient student advisement. Number 2, program educational objectives, again involving the constituents in the establishment and review and evaluation of the PEOs is fairly common. Criterion 4, continuous improvement, again trying to demonstrate that there is a robust process in place and it is followed, that frequently is a source of shortcomings under criterion 4. Criterion 5, curriculum, there is a balance needed between or specific requirement of numbers of engineering hours versus math and science. That one is not as frequent as it has been in the past. Something we do see much more frequently now are culminating design experiences where the use of appropriate standards is found to be lacking. Faculty number, rapid growth, this is a problem, an issue that many biomedical engineering programs are facing. Related to that, facilities, often with rapidly growing programs, the availability of appropriately sized laboratories and so forth is frequently a challenge, and those often lag behind student growth just a bit. So those are some of the shortcomings that we are finding within biomedical engineering programs. We communicate these findings, not specifying where we're seeing these findings in terms of names of individual programs, but we share this information with the Council of Chairs on an annual basis. As you recall, the Council of Chairs, in theory, every ABET accredited undergraduate program has a representative on the Council of Chairs. So that's our main vehicle for communicating back to the programs these sorts of findings. So some basic reminders here, and this particular slide is really oriented towards the program evaluators that are participating on this webinar. The program evaluators, or PEVs, must complete a thorough review of all the material prior to arriving on campus. In other words, you need to come to campus prepared. The team chair is going to require the program evaluators to submit a set of forms to them during the visit. And you will often get some of these forms, like the PEV worksheet, that the team chairs will request in advance of arriving on campus. But please listen to your team chair and provide these materials to them in a timely fashion. It is speaking as a team chair myself, that is a major challenge for us in terms of trying to coordinate literally all the paperwork that is associated with these reviews. The third bullet here, the accreditation action recommendation, is a team decision. And this is actually very important for everyone listening to this webinar to understand that all these actions that are taken on individual programs are team-based decisions. So the PEV for a biomedical engineering program will be consulting with the entire team, the visit team that is present on the visit before making those recommendations. All the report material that the PEV is required to submit to the team chair must also be furnished to the BMES AAC mentor that they're assigned. We use this material, the AAC uses this material to review what's going on with each visit cycle to help us identify opportunities for continuous improvement in our training, not only in our training of the PEVs, but also to share back with the community, with the discipline, some common problems and shortcomings like we just mentioned a couple of slides ago. Okay, some final points here. Programs must provide information to show that the program criteria are met. Again, the emphasis here is on the programs must demonstrate, not the PEVs must find proof. The programs need to provide that. Program criteria will differ between programs of different types. There are 29 sets of program criteria that the EAC is responsible for. Ours is but one of those. So don't confuse requirements that might be in another discipline's program criteria with ours. Biomedical engineering, bioengineering programs have only one set of program criteria that are applicable to them. And as far as accreditation actions and shortcoming identifications, these program criteria are subject to the same labels that would be for the general criteria in terms of levels of shortcoming, concerns, weakness, deficiencies, and so forth. So it is treated in terms of the implication and the overall accreditation decision, just like criteria 1 through general criteria 1 through 8. All right, we now have time for questions, and I'm going to turn back the microphone over to Jenny on this.
All right. Thank you, Paul. Can you find some great questions while you were talking? So I'll start by addressing just a few, and then I'll let you catch your breath and then jump in. So we received a question, which I was kind of anticipating, about this transition from the A through K to the 1 through 7. So the participant asked, what are some strategies for smoothly transitioning from A through K to 1 through 7? And can you give us an overview of how they'll be assessed? So I'm actually going to pop 2 links in the chat to all really quickly to make sure everyone has these links. These 2 links really are the go-to place for the answers to those questions. The first one is the definitions for the criteria. So these are the definitions I mentioned earlier that have been clarified by ABET to make sure that we're all being consistent across. And then also there are ABET kind of advice for switching from the A through K to the 1 through 7 that were put on the website. So you should refer to those as your go-to advice for how to switch. But I also pulled up our Engineering Accreditation Committee Commission pre-visit training, which states that the 1 through 7 are in effect for the 2019-2020 cycle, and that we anticipate that programs are doing their best to switch from A through K to 1 through 7. So I think what most of us are looking for is that the program has an established record of using A through K up until they realize the criteria has changed. So they should have a plan for implementing the 1 through 7 and show as much data, attainment, and continuous improvement as is practical. And so we hope that programs will be showing progress towards a full switch, but programs this year and this cycle may not be completely switched over. So what's important there is to have a plan in place. And you'll find this all described on the ABET website in those links I provided.
Okay, I'll take the next question here. There is a question, let me read here. In taking measurements on living systems, what are the rules for doing this? Does the project need to have IRB permission for humans, IACUC permission for animal testing? So my answer for that, and this relates back to the program criteria and making measurements on living systems, I think I am going to defer to whatever your individual institution requires for those types of measurements. I know that in my own institution, Georgia Tech, when we do any type of measurements on animals, even earthworms and some others, that we run it by our IACUC for approval. In many cases, they say no problems, but other times, we certainly have to follow their guidelines. So ABET really does not address this specifically. I think this is something that one has to follow the local guidelines at a particular institution.
Great. We received several questions about providing the BMES AAC with materials from visits. That is something that's been going on for a few years, at least as long as I can remember. And it does come directly from the PEV to your mentor or directly to AAC so that we can collect those materials. We, of course, hold it in confidence and don't use the names of the programs, but we do collect all of your forms, so your program evaluator worksheet. You also were sent out when you were assigned a mentor, one that already had the program criteria on the bottom of the worksheet, so feel free to use that one while you're doing your reviews and send that back to us for our consistency check. So yes, those do come from the PEV to your consultant or mentor, which ends up with the AAC.
Okay, another question. If a program has extra outcomes for some program criteria, but not all the program criteria, is that an issue? No, the program is free to provide additional outcomes beyond 1 through 7 if you choose to include some of the program criteria in those, but not all. That is the program's choice. But again, remember, once you move things from the language from the program criteria and incorporate them into student outcomes, the bar is now raised that you must assess and evaluate the attainment of those outcomes.
We have a question here from a program evaluator who's visiting a new bioengineering program for initial accreditation and asks, is there anything I should be aware of? I think the most important thing for initial accreditation visits is that this program may not have a full cycle of everything implemented and improved, but they should have as much as is practical collected for showing that they have a continuous improvement process in place and that they are following it. It's also very critical to note the date of initial accreditation. When a program goes up for their first initial accreditation, they can request 2 years worth of retroactive accreditation instead of just 1, meaning they can go back October of another year. So you should make sure to double check with them what their desired start date for accreditation is. when doing your visit, because that's something you'll have to put on all of your worksheets and will go to the Commission for voting on accreditation action.
Okay, another question. Would like to know if students are considered a constituency. Well, programs are free to define who they consider to be constituents. I must confess, I don't think I've ever visited a program where students were not considered to be one of the constituents.
There's a question here that says, are there general guidelines as to facilities and what qualifies as sufficient lab space? Similarly, are there general guidelines as to faculty number and workload? I will say there are not published guidelines on these things, but based on my experiences and looking through other programs on the Commission, really what your program evaluator is looking for in facilities is, are they adequate to support the needs of the program? If you're doing certain types of experiments or expect students to have hands-on expertise in a particular software or piece of equipment, they need to have access to that equipment, they need to have training on that equipment, and they need to be able to show proficiency on that equipment. That would be important to the program. Usually, that can be found either through the tours on Sundays, speaking to lab managers or course directors to get an idea of upgrade or maintenance plans on different facilities, and then talking to students about their experiences in the lab. Do they feel safe? Do they feel like they have adequate training? Really, those are the things that tell the program evaluator if the facilities are adequate. There's not really a certain guideline. And then for faculty number and workload, that's a really hard one. You really just have to go with your gut and listen to what happens on campus, because many of us are at large institutions where maybe we have more research duties and only teach one course a semester, but there are institutions where the expected teaching load is 2 or 3 courses a semester, and that's normal. So I'd say for that, just making sure not to go in with your own bias of your teaching load at your home institution, and just listen to, our faculty saying they're being overworked? Does it look like they're able to keep up? Are the students getting adequate attention in office hours? Those are the things to look for in terms of, is this workload appropriate? So that would be my best advice there.
All right, we have another one here. Could you please define depth requirement in the program criteria? E.g., would you consider a sequence of an electrical engineering course following a biomedical engineering course that has the EE course as a prerequisite? So let me just interpret this as meaning, can depth be demonstrated by having a set of courses from different disciplines, in this case electrical and biomedical engineering? So I think the answer to that is tough to give a general response to that, but I would certainly, being an electrical engineer by training and background, could easily envision that having electrical engineering background and coupling that with biomedical engineering topics could easily be demonstrating depth in a particular subdiscipline within a biomedical engineering curricula. For example, the one that comes to my mind right away would be in medical imaging, where you could be looking at an electrical engineering signal processing course, for example, or image processing course being coupled with a biomedical engineering imaging course. To me, that would I would interpret that as being as equivalent to depth of 2 BME imaging courses.
So there's a follow-up about initial accreditation that asks, can it be before the first student graduated? No, it cannot be. ABET requires graduates to apply accreditation to a program, so that first date is intended to cover the first graduates, so it can't be before that happens. There's another question that I'll just go ahead and lump into this one about minimum number of BME faculty for accreditation. There is not a minimum number of BME faculty in order to obtain accreditation. The faculty criteria state that you have to have sufficient number and then, of course, expertise to offer the program. But again, at a smaller institution that is teaching focused, that can be a smaller number than you might see at a large R1 institution. And so your job as a program is to prove to your evaluator that you are covering and offering a quality program with whatever number you have. There is not a minimum.
Speaking of minimums, another question here, is there a minimal amount of statistics? I think that question in terms of how much statistics must be as part of the curriculum, as a program evaluator, I would really probably look at the measurements, the making measurements curricular topic. Look at what the students are collecting and the data and they're analyzing and so forth, and use my judgment as do they have the statistical backgrounds in order to be able to interpret these measurements that they're making, determine statistical significance and so forth. So I would look elsewhere in the program in terms of where statistics can be used and ask myself, do the students have enough statistics background within their curriculum to be able to perform those types of data analyses and evaluations.
Building on that statistics question, there's another one that says, is it preferred that stats and DiffyQ should be specific to exclusively BME topics, or would it be reasonable to include those in a general stats or DiffyQ course? The program criteria, and in fact the slides that we showed today, do say that the curriculum must include differential equations and statistics, but that either standalone courses and integration of the topics are both acceptable approaches. And so it's whatever fits best within your context, but your curriculum must include those concepts somewhere.
Okay. So here's an interesting question. Does living systems mean alive? Right, let me follow that up there. Can you use biological specimens, in other words, in vitro tests, I presume as a substitute to actually working with a living system? From my perspective, the living systems, there presents all sorts of challenges, well, depending on the system and depending on the measurement the one's trying to make, challenges in making those measurements. And the real question is, can a biological specimen provide that same level of experience for the students in addressing some of those challenges? If the answer is yes, then I think that could qualify as maybe a formerly living system, perhaps. But I think that's the real intent behind the living systems, is to address some of the challenges associated with the variability and uncertainties associated with those type of measurement taking.
We have a question that says, are program evaluators allowed to ask programs permission for a class visit during which there will be a lecture delivered by a course instructor to students? So I'm guessing this is in a question related to your PEV had said, I would like to come into this class to interview students instead of having a separate meeting. Your PEV certainly is allowed to ask that, and you are allowed to say, no, we would rather not do that. I think I'll kind of give both sides of this. You know, I tend to not do that as a program evaluator because I don't want to disrupt class. However, I know program evaluators who do like to visit classes because they feel like sometimes you get a hand-picked assortment of students that maybe you're not going to get the variety of students you're hoping to talk to if you're just given students outside of class time. So it's kind of easy to see both sides of this. I would say if you can spare, you know, maybe 15 minutes of class, kind of compromise on that, that might be nice. Otherwise, of course, you are allowed to say, no, that won't work for us. You know, can we figure out something else? And that's fine too.
Have a capstone question here related to the culminating design experience. Is a capstone project required? Well, criterion 5 requires a culminating design experience. I do not believe the term capstone actually appears within that criterion, but the culminating is typically what everybody refers to as a capstone project. And yes, criterion 5 does require a significant culminating design experience. So I think the answer to that question is whether you call it culminating experience or a capstone project, yes, those are required.
We have a question that kind of builds on the earlier one about living systems that says, can simulations be used as a surrogate for measurements on living systems? Certainly simulations are powerful these days and can get very close to human systems. So I would say if the simulator is really tailored to present a situation such as electrodes, you know, not making good contact due to impedance issues on the skin, and the simulator can simulate that event, then that does help the student understand the interaction between living and non-living systems, which can be assessed. So I think it meets the point of you know, what we're looking for, that students understand those interactions between living and non-living systems, as long as those are really tailored to that specific learning goal. I think that's fine.
We have a question about student advising. Does it have to be for all students? How is sufficiency defined? There's a reference here to a student advice center. Maybe I'm just kind of trying to read between the lines of this question, whether it requires mandatory student advisement or just drop-in advisement. So that's an interesting, and maybe I'm reading more into the question than was intended, but as far as student advisement is concerned, I think as a program evaluator, one of the best indicators that students are getting good advisement is students actually telling me or well, maybe not necessarily telling me they're getting good advisement, but not complaining about things like access to advisors, or if I'm seeing evidence of them doing things which would suggest that they are not being properly advised, for example, taking courses out of sequence and so forth, then there's a problem. And then as a program evaluator, I start looking into whatever system and processes that are present. Many programs have requirements that students have to periodically see an advisor. Other programs provide group advisement and so forth, and maybe only certain triggers that will require mandatory advisement. So there's a lot of variation out there that we generally see, but as a program evaluator, you know, if it's working, I'm not going to be very critical about how the processes that are in place if it's working. But if it's not working and the students aren't required to see advisors, then there's a problem there. There's likely a shortcoming in that kind of setting. So I would recommend for programs to really pay attention to their students and their feedback about the exit surveys and so forth in terms of their satisfaction with advisement, and use that as an aid to determine whether or not problems exist. Okay, well, I see the
we're out of time.
yeah, I see the last slide come up. I just want to thank everybody for tuning in. Remember, this is being recorded and will be available shortly for those that may have missed it, or if you have colleagues that might want to view this, you can refer them to that. Also, there's going to be a session in Philadelphia on Thursday the 17th. At the annual meeting. The time is specified here. It will be a panel of program evaluators that will be there to answer any questions that anybody attending that particular session cares to ask.
Well, thank everybody so much, and we'll look forward to seeing you at BMES.